And we would like to achieve a situation when in a short time at a low cost, so to low prices, we will be able to erect housing estates and other kinds of buildings. It is very important, and I will mention it in my presentation, that we start our design phase early enough so as to optimize our data for the precast production. We want the precast products to fit in perfectly to our projects, and that is why we need a very detailed and early enough prepared designs. We want to avoid very costly claims that arise when the buildings are already operating. And we want to start with best practice issues. We want to take responsibility at a very early stage of preparation of a precast product. We want to set rational thinking ideas and forward planning so as to design the precast elements properly. The planning is the most important issue for us in order to achieve the so-called quick wins, quick benefits. We have to start at a very early phase. So starting with the concept of a housing development, we need to set our thinking in the planning of the entire lifespan of a building. In our company, we have built around 3,000 houses within the last 15 years. And we know that the worst thing that can happen is that when you are trying to introduce an assembly, anything that has been omitted during the construction phase after it's been given away for operation. It is the most costly procedure. If we manage to eliminate that, it's going to be an enormous success. On a normal construction site, for example, in Germany, and I'm thinking about, for example, the construction of airports, you have to organize the construction work in a very detailed way. The elements that have been pre-manufactured are being brought to the construction site, and they have to be appropriately stored. And per week, we are assembling a certain amount of those products. This has to be taken under consideration in the planning of the entire construction project in the design phase. Here you can see on an example a project with around 198 houses, and we had to plan the energy supply to those houses in advance. We had to plan it in a cost-efficient way. And right now, the people who live there turn to us with a positive response concerning the savings or the effectiveness, energy effectiveness of those houses. That is, it needs very little energy to have it maintained per year. What I'd like to say in addition to that is that this project was situated around Frankfurt, and they are made of concrete. They have a functional division, and the massive elements made of concrete secure them from noise generated by the Frankfurt airport. Here you can see an example of a different building with a special assembly technique. And it is also something that influences the erection time severely. It has to be taken under consideration in the design phase as well. I know that you all are already hungry and you're waiting for lunch, but let me say a few more words. You have to think about the Earth and how you treat our planet. There was a period of fascination with liquid stone by the contractors and by the manufacturers. I am convinced that this material is a good one. I know that it's been used for the last 2,000 years in ancient Rome already. I know that Pantheon was made with the use of concrete without any reinforcement. And this building has lasted several severe earthquakes and is still standing and has practically no damages made to its structure. So I am convinced that this material is useful also in case of the need to assemble more installations in a project. As you can see, you can introduce window elements, you can introduce timber elements, you can expand and develop the project with different kinds of materials with the use of concrete as the base material. As you know, on a construction site, you work whether the weather is windy or frosty, so you have to take this also under consideration. This is an example of a concrete wall, and it contains steel as well. It's been assembled in a project, and thus a lot of money was saved. The basic need of people is a safe home. Those homes have to be resistant to weather conditions. People are looking for safety, pleasant microclimate, and carefree tranquility in large cities. And they are ready to pay a lot of money for that. So if you're thinking about all the advantages of a house, you can see the development here from 2011 up to 2040. You can see the average change in insured damage in percent, and it concerns windstorms and hailstorms. As you know, we have in January and February temperatures below 15 degrees Celsius. And here you can see a graph on climatic disasters in Germany from the 70s up to 2011. Here you can see the energy use of the mankind. As you can see, we use a lot of fossil fuels, and we generate huge problems with regard to this. Here we could also mention China and many other countries which pollute the environment severely, but we can also talk about Europe in this respect. When we think about our buildings, our housing developments, we have to think about the heating systems and the heat losses, the losses of energy, and the energy consumption produced by one family, which amounts to 76% for heating. 80% of heat gains from solar radiation comes from the roof of a building. A massive house of large heat capacity would ensure visible benefits. If you could bring the cold from generated at night to operate in the daytime in a house, that would also make a huge saving and a huge advantage to the environment. If you can design the house in a proper way so that the windows are enough of a barrier for the heat and for the cold in certain time of year, that would also produce enormous energy savings. We have a very small span in which a human being feels comfortable. You have to think about a proper air temperature, the proper floor temperature, otherwise a human being feels too cold or too warm. And you have to think about the exchange of air. So when you're thinking of a building, you have to think about the air exchange system, about the usage of windows if necessary, and you have to think about the proper material to ensure all those properties. When we think about concrete, we know that concrete is not prone to fire. If we use it as a roof material, it also has significant advantages. That's a safety for the inhabitants of a house. Also in terms of strong changing weather conditions, like for example storms or tornadoes, which also take place and happen in Germany and in other countries in Europe. Tight roof is not enough. You have to think also about the stability properties of a house and the resistance to noise in case of places prone to, for example, airport noise. And here on the slide you can see how much air traffic there is over large cities in Germany, for example. As far as electrosmog is concerned and lighting installation, you also have to think about negative influences of the environment of a house and the acoustic properties. Concrete has also a great advantages, namely that after, for example, 20 years, it's not covered with any kind of layers that are produced by the environmental conditions. It doesn't smell. It doesn't take in any fragrances generated by the inhabitants of a house. It also has the great advantage that it's not insect or animal friendly. That is, there is a little possibility for animals to start living in structures made of concrete. Building from elements requires quick and reliable connections. That's also one thing you should take under consideration when planning the building developments made of concrete. You have to think about the joining elements so that you don't have to use severe equipment to introduce joints in difficult weather conditions on a construction site. You also have to abide by certain quality rules, not only on site, but also in the production plant. I'd like to show you something that is pretty important in this respect. When you glue something to the pallet, you have the possibility to cut the elements to the wall. And when you're doing it on site, it works in such a way that you tear it, you take an element with a joining element and the other element you want to glue to it, you put it together, and now you need a third hand. You close the lock, then the joint is ready. The tolerance is about 1-2 centimeters, and then with a special device from the internal side of the wall, you have to pull it together. When it's pulled, the element is load ready. It is a huge advantage in the construction industry, and we are using it already in a project in Neuss. It's in the vicinity of Dortmund, and it's been already used. If you're interested in this element, I will place it on the stand of the Pico company, and you can come and see it. When those two walls are put together, you screw with an electrical machine the screws to the wall. It lasts for about 10 minutes. That's why it's called 10-lock. Now you can see the assembly at the site. There's also a small opening, and you, with a special pistol, with the paste, you put the paste inside to sew it tightly. This is how it looks in practice. You see that it's joined together with a screw, and then it's brought together with a concrete element. There is a screw-based joint. And finally, it's joined together during the transport, and then on site it is put on the whole structure with the use of special equipment as well. Here you can see another quick way to join elements, and if you want to do it in a cost-effective way with relation to roof elements, you can use this kind of equipment. The roof element is put on and then when the building is already erected, you take a paste pistol and you put the material in the opening between the two elements, and so you create quickly a very stable connection point that can be reliable. Here you can see a roof where you can also put window elements inside by means of the very same method. This is a very cost-effective method and a high-quality method of erecting one-family houses. You can take off the grids and build it in a way that I just mentioned. In the next step, you introduce the isolation, the foil, and then the product can be transported to the construction site. You can also work with reliable and sensible tolerances on site. And as I said, it's a quick way and a pretty cost-effective way to execute construction projects in the scope of one-family houses. When both roof elements are put on the building, we have a band that comes, the isolation band that comes on it, and it's screwed together with the roof element. Here you can see a little bit of research and development. We are testing those solutions. We are testing new joining solutions at our company's research and development department. We try to put in precast timber elements in the elements, the concrete elements that we are using for construction purposes. As you can see, the 5 centimeter concrete shell is used in the case of this construction project. Here you can see the prepared roof elements with the screw joints. On this slide, you see the 10-lock joint still not dried. And we try to develop all those solutions together with our customers. For example, if they need an isolation of 5 centimeter thickness, we try to check whether it's feasible or not, in a way that the wall is standing on a cold plate, we have a isolation, a 5 centimeter thick isolation, and the warmth bridge is being checked whether there is enough isolation and protection from temperature loss. This helps to reduce significantly the energy consumption. Here you can see the production process. You can see the precast elements, the roof elements as one single piece made of concrete. Then you can see how it's binded together. It looks a little bit like with a double wall. And the product, the ready-made product, is brought to the construction site and implemented. Here, as you can see, the capacity tests in our research and development department. Also, the load-bearing elements are being tested in our research and development department so that they can be safely introduced in a construction project. Also, here you can see ready elements with isolation, with foil, and with all the necessary elements that normally would be assembled, introduced on site. Here you can see the roof elements with openings. Later on, the elements are joined together with wall elements. To sum up and end my presentation, I won't be going too much into detail, but as you can see, the element can be put on the roof immediately because the joining of the elements is then made from bottom up. Here you can see a window already introduced in a roof element that is going to be directly put on the house roof. Here you can see a picture made from a crane. The windows and all the other elements, including the rib plates, are already there. And you can immediately place them on the site, on the building. Here you can see the isolation band. Now you can see an element with a window. Here you can see how it's solved when we need to put something on the wall, like for example isolation, but we have our means to remain for the concrete elements to remain at the same place, not to be moved. Now we have elements made of steel that are placed in the edges of the concrete elements, and this is how our products look like. We have made experience with over 2,000 houses. And here you can see the border building element. This is a wall of a certain height. You can't just build it and then bring it to the construction site, but you can do it if you use concrete elements. So, if I want to have an isolation already made, I'm pretty sure that the house is water resistant, and I can achieve it in this case by means of precast elements. The isolation is already on the product. The windows are already isolated. So here you can see ready-made precast concrete elements that have been used in this project. This is the list of advantages of this method. When we have a house that we're erecting on site, piece by piece, it won't have all those advantages that we have when using precast concrete elements. We have acoustic insulation from the outside noise and neighbors. Then we have optimum fire protection, comfortable microclimate in the entire house, thanks to the protection against heat in summer. We have energy savings, tightness against wind. We have high capacity for the accumulation of heat, cold, from day or night. We have houses that are resistant to wind and hail, to martins, wasps, mice, like all kinds of animals. And we want to deliver by means of our precast concrete elements advantages that they won't achieve with any other kind of material. Thank you very much for listening to my presentation and enjoy your lunch. Thank you very much.